So Brian, what is the Cisco Digital Building and how is Superior Essex involved in that? How did we get involved with the Cisco Digital Building?
Yeah, it's really a cool story. Cisco, right, being the big data, Ethernet, switching, networking, gorilla in our world, right, in the whole telecom world, the communications world, they sell the switches, right? They manufacture and sell the PoE switches, right, network switches. So their goal was to drive lights over the network. So if these lights, there's lights around us here, right? I mean, there's in buildings all over the place. As long as they're LED lighting, they can't be fluorescents, they can't be halogens, incandescents don't work, they're too high voltage. So for them, they sell the switching equipment, right? They said, I got a switch that can give out 20, 30 watts, or 60 watts of power at the time. Now they're gonna do 90 watts coming forward, but now I wanna use that to drive the lights. So they don't sell lights, they don't sell the software, they don't sell the devices, right, or manufacture, so let's create an ecosystem, they called it, to help do that. So they started looking at the structured cabling piece, right, that connects the switch gear to all these lights and devices, and how important is that now we're getting to higher wattages. So what do we need to change there that's different than what they do today? Category 5E, Cat 6, Cat 6A, do we need something special? So through our relationships with them, they engaged us, and I got involved with them on that with our product managers. And so, okay, now you're going to push us so much power. What do you need to do? So then we developed a product to help them with that. But they created the ecosystem on the far end to all these devices, right? What else can we do? Blinds. And so it started to build these manufacturers, multiple lighting manufacturers. At the same time, there's control manufacturers, software manufacturers, chipset manufacturers. So all in today, there's 27 companies. All together, we create that ecosystem around Cisco, and then we can go out and drive the solution from that point on.
And that's a great description. I have probably incorrectly described this system to folks as Cisco's switch is like the brain in some way, and then there's the technology node or application, and then the cable is the plumbing that provides power and data to the smart end device. Is that
That's good. No, that's really good.
Could you explain that a little bit more of how all of these things interact together in the Cisco?
So Cisco Switch now is that hub that we could control through software to do all these things. Yes, and we're the plumbing. That's a great way to talk about that, right? Because now we're connecting this hub to a device. It could be a light, it could be a outlet, it could be a wireless access point, it could be a blind, whatever. There's all kinds of things we can drive with it now. So we're taking that physical connection from that switch to depending on the ecosystem partner, everybody does it a little bit different, to a control module of some sort, and then from there to the device that we're controlling or powering or things like that. So yes, we are that conduit, highway, plumbing, to connect those for sure.
So what is the typical length that a PowerWise cable can work in this system within? And is there a difference between copper and fiber? And do we have a PowerWise application in both copper and fiber?
Yeah, we do. As you start looking at the distance is 100 meters. That's your whole channel. So 90 meters or 328 feet is 100 meters. 295 feet is your 90 meters. So when I go from my switch to my control box or my next stopping point, it's got to be less than 90 meters. That's a design standard that's been in place for years, and that has not changed. That way Cisco can manufacture switches knowing the maximum distance it's going to see is 90 meters.
And fiber can run longer than copper, is that correct?
It can, no doubt. Fiber, and again, single mode, multi-mode or single mode, now we're talking 1,000 meters, 2,000 meters. Now we can run a lot longer distances. So that's great for applications that we want to run outside or to a different part of the buildings. And there is a really big push for fiber everywhere, right? So now we can do that with fiber conductors and power conductors under the same jacket. So it's not technically PoE. What I would call that is power with Ethernet. Maybe that's a new term.
PWE.
I like it. That might be cool.
We're going to frame that.
Write that down right now.
Trademark that, Ryan. Yeah.